Hey there, and welcome to a new channel video where today I will show you the brand new DSO1C81, an 80 MHz oscilloscope with 5 MHz signal generator. ZEEWEII is the underdog of these small oscilloscope equipments, but continues to deliver solid devices that respect the announced specifications, so I'm really curious to see if this device will be one more win coming from ZEEWEII. As a disclaimer, this device was sent for this review free of charge for me, and no payment was made by ZEEWEII to produce or promote this video, and they will see it at the same time you will when it's published on YouTube. That said, thank you ZEEWEII for sending this device, and also a big thank you for you, my viewer, that sponsor this channel whenever you use the affiliate access links on the screen every time you need to access AliExpress or Amazon to do your purchases. You pay exactly the same, but just by using these links you are sponsoring the channel and giving me a big help to keep producing these videos. A heartfelt thank you. Enough chit chat, let's get this party started with the key features. Allow me this small break to send kudos to this video sponsor, ZEEWEII. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. I have here the box of the DSO1C81 to unbox. This is now boxed in this retail box, much better than the previous ones. Yeah, no brand, but you have here the information about it. Previously it comes in this kind of box. This is from the DSO 3D12, the box. It's nothing wrong with it, but it's much more industrial. This one is more retail-like. Okay, let's see what we have inside. Let's open it. Okay, and we start with a P6100 probe. We have a user manual, not the best quality, but it seems enough for what we need. Okay, we have some infographics. This is very important. This is the key combinations. The ZEEWEII devices always have a lot of key combinations. So seems that we have enough for start working with it. Okay, we have also a cable for charging and probably to take the data from the device, USB Type-C to USB Type-A. And finally we have the DSO1C81. Let's see it. Okay, nice. As first impressions, it seems that the protective film has a sticker, but it is below the case. So I might have a bit of a trouble to take it out. Let's keep it like this for now. We have some silicone or silicone-like keys, very nice to the touch. Okay. On the bottom and on the sides we don't have anything. We don't have anything also on the back, but we do have a socket connector for BNC on the top, an output for calibration, and this is the socket for the USB Type-C connector. Also you have a light, a charging light there. It is red when charging, green when it's charged. And yeah, for first impressions, that's it. It seems very tough, good plastic. It will not go in when you press it. Basically, this is more or less the same construction that we have on the previous models. This is the 2-channel model, 120 MHz bandwidth. The screen, it's a 2.8 screen, 2.8 inches screen. And if you take this case out like this, As you can see, the plastic is basically the same. It's a very tough plastic. It seems that they stopped sending these silicone cover, anti-slip cover. It's a pity, but I do understand, because in the smallest model this has some issues. It was quite loose, as you can see. The device is pretty good, but the cover, yeah, it does the job. It's here, but has some issues. It became loose. It didn't happen in the other model, but in this one it did happen. It became a bit loose, but yeah, probably this is a device to be cheaper, and they cut in the cover. But if it works well, I don't see any problem. So I have the DSO1C81 already here. Let's power it up and see how it works. Okay, nice screen. Very colorful graphic in here. Let's start by analyzing the screen. From the top we have here the run state. So right now it's running. If you press where run stop, it should, yeah, now it is stopped. Also for the single mode. Next we have the horizontal line for the sample memory, and the trigger modes, the edge or the slope, and the battery level indicator. We have in here this blue arrow, the trigger, and obviously the line of the signal with the arrow indicating the signal position here. Those values on the screen are measurements, and we can configure this, and I will show you ahead in a video. We have the amplitude, the coupling, and the probe mode. So right now we have the probe at 1 times. Next we have the time-based, and this is the output from the function generator in here on the corner. For calibration we put the common in this one, and the other one goes with the probe, yeah, like this. So it seems that we have more or less calibrated probe. We can move the signal up and down using the direction keys and increase the amplitude with these keys. The time base is controlled by S or NS. In this case we are going with the NS. Now that we have this on the screen, we can see that the measurement is with 1 kHz frequency. That's the normal from this output for calibration. Also we have a peak-to-peak of 300 millivolts and the mean voltage about 140-50 millivolts. Okay? Well, in terms of the screen and the keys in the keyboard are more or less this. You have the auto. As you can see, it was really fast to update, and also the run and stop that I previously showed. We already saw the movement functions, and we have 2 special keys right now. Well, 1 special key and the menu key. Let's start with the menu key. For the menu key, the first option is measurements, and you have 14, if I'm not wrong. So 4, 8, 12, 13, 14, yeah, 14 measurements in the screen that you can choose. For selecting the measurement, you use the direction keys, and when you want to activate it, you just press the OK or Auto key for that. To move these options in the screen, you use the volt and millivolt buttons. You have also the direction keys there. So we have also the options for trigger. Right now we have trigger in auto, can be normal. The trigger level also can be manual, and the trigger edge also can be rise or falling. Right now we have the edge, the slope, in rising. One thing, if you have this manual, you will be able to move, let me show you, this arrow up and down and select the trigger level manually. The display menu, you have the persist, it can be 1 second or infinity. You have the roll mode on or off, and the FFT, and this device has FFT, so it can be turned off, it can be logarithmic, linear, or music, and you can control the brightness of the screen in here. Maybe I will control the brightness a bit low, let's see, no, Okay, yeah, here, to give better image. Yeah, it will show a better image for you. I think that's okay. And next we have settings. Let's see what we have in settings. So we can configure the probe compensation. Right now it's 1 time, 10 times or 100 times. We can activate the auto shutdown. We have 3 languages, Chinese. I don't know if both are Chinese or Japanese or anything like that, but this one I think is Chinese, not sure. English, and you can use this menu also to do the calibration. You just go there, okay, like this, and press OK. I will not do that because I don't want to calibrate right now. And finally, you have the signal generator. And regarding the signal generator, he says that it can do 5 megahertz sine waves and 1 megahertz square waves and other signals. So we will see the signal generator ahead in the video, and I will test it also. So in terms of signal generator, that's what we have. Let me see just if I can put a sine wave, and I can. But we will see this signal generator ahead in the video. There is some more functions that you need to know. If you press the function key, you can see that you have a few options in the screen. And the way you have to read this is every single rectangle of this in the screen is assigned to a key on below. So right now single is the auto. As you can see, it stopped because it is on single. Then you can press again run and it will work. You have also the frequency meter that can be activated. It's a 6 digits frequency meter that you have here on the corner. And let's see what else. And to remove it, just press again the same combination of keys. You can see you can change also the coupling to DC, AC, DC by selecting the run stop after you press the function. Okay, now it's AC. Now it is DC again. You have also to change between X1 and X10 compensation modes directly in here. Don't forget that in the menu you can use also the 100 option. And here also, you just press several times until you get the 100 times compensation mode. Okay, so you have the 50% to put the signal at 50%, okay, and you have also a counter. So right now you have the counter active. Again, if you want to take it off, just press again in counter, and you have the view. This view will show you the image that were saved. Let's get out because I will show you this again. So the other option is to save. If you press save, okay, now we save this sine wave. If we go again to view, you can see it there. To select, I believe that's okay. Yeah, it's okay because you have here one of 2 images, and you press the direction keys and you are able to move in the memory. Okay, that's nice. Pretty easy to use. I'm curious if you can take this image out of the device. Okay, to exit should be menu, I think. Yeah. Right now we are again in the normal screen. And in terms of functions, you have also the zoom. That's the V key. Okay. Okay, let's take the zoom out. And finally, you have the cursors, the vertical cursors and the horizontal cursors. Okay. So for this little guy, you have a lot of functions available. I will show you the cursors in a different chapter, working with it. And in terms of operation, that's basically everything. I need to talk you about some other options, but it's a combination of keys. We will go here to the trigger menu and change the trigger mode, now trigger level to manual. Okay, now it's manual. Let's take it out. And if you use the keys to move up and down or to the right or left, you will be able to move the signal and the signal in the sample memory. But if you want to move the trigger, you just press function and the direction keys, and you can see that the trigger is moving. Okay, so that's how you move the trigger in manual modes. Okay, function, let's put this at 50%, and now you can move again the trigger. As you can see, it's out of the signal. Also, if you do a long press on auto like this, you activate the real-time automatic adjustment. So as you can see, it is with auto adjustment always in the center of the screen and the signal adjusted. Okay, so to deactivate this mode, you just press again auto. Okay, now it's deactivated. Also, if you press function and press run stop, as you can see, you activated the 20 mega limit. To deactivate again, press function and stop, and that's it. If you press function and millivolt like this, you create a reference line in the screen. To take the reference line off the screen, just press again function and millivolt and it's off. And finally, if you press function menu, you activate the high contrast or this different option. I prefer the black one, but if you are into it, you can use this white background for working. Just press function menu again and you are back to the normal menu. So this is the main function combinations and key combinations. I think that is easy to memorize, but if you have any trouble, just go and test it yourself, and after a while you will be able to work with it without any problem. I have my function generator already connected to the DSO1C81. It's outputting a sine wave with 100 kilohertz. So let's do some measurings right now. I'm going again to the measure menu and let's activate some measurements. For example, the RMS and the amplitude, duty cycle, and max and minimum, yeah, and the base. So let's see what we have on the screen. As you can see, we have a lot of information. The frequency is being detected at 100 kilohertz, so this is quite nice. It's very correct. And also the maximum 25.2 volts and the minimum 25.4 volts. These values on the screen, the 25 volts, are happening because I have the probe compensation to times 100. Let's change that. If you remember to change that, you just press function and go here to the menu key and again. So right now it's okay. I'm outputting a 5 volts VPP signal and we have a max of 2.52 positive volts and 2.48 negative volts. So this is a sine wave. It's the peak-to-peak voltage. So we have a voltage of peak-to-peak of 5.01 volts. It's pretty in line with what we have in here. So in terms of measurements, that's it. I can also do all measurements option. Okay, and we will have everything on the screen, or press again all and it removes and it keeps the last configuration. Pretty nice detail, a very nice detail, this one. Okay, I'm impressed for this small device. It's really something thoughtful. Okay, we are again to the normal options, and in terms of measurements, that's it. Let's now talk a bit about the cursors. For activating the cursors, as I've shown before, you came here to the function, you press function once, and then you have this menu, and you press S for the vertical and NS for the horizontal cursors. To move the cursors, you use the arrow keys up and down, and this will move the cursor, the horizontal cursor up and down, and the vertical cursor will be moved with the left and right. As you can see, it's moving. Now we have the problem of the bottom horizontal cursor and the right vertical cursor. For that, you press function and keep pressing function, and you are able to move the bottom cursor to where you want, and the same for the right cursor. So if I want to take the right cursor in here like this, let's do like a 90%, yeah, like this should be, and then you should have the rise time over there. And yeah, that's the way you handle the cursors. If you are with this done, just press function and disable it again. Now let's see the persistency, and for that let's go to menu and move down, down, and we have it here. It's off 1 second or infinity. Let's start with 1 second. Okay, menu. I will activate the sweep, and yeah, we should have something here in the screen. Okay, seems nice. Let's put this in infinity. Okay, and yeah, it works also well. Increase a bit the resolution. Okay, seems to be working well, and that's how you use the persistency and the results that you have. Let's deactivate this, and yeah, and it is again now without the persistency. Now is the time to show you the FFT. We are still on the same menu, the display menu, and I will activate the logarithmic FFT. Okay, let's take the menu out of the screen, and right now we are seeing the FFT for a sine wave. We can change my signal generator for an arbitrary signal, for example, and or we have here harmonic also. Okay, this is a bit confusing because the FFT is on top of the signal, but we do have some configuration here in the screen, and you can move this option. Okay, let's do a stop, and you can move this option to analyze the FFT. As you can see, it's very cool for this little device, this function. You normally don't get these kind of functions in small devices like this, so I'm pretty happy with this in here. Also, let's do a run again. If you come here to menu again, you can also activate a linear signal. As you can see, it's different, and I will, for example, do a sweep. Okay, I'm not able to do a sweep in an harmonic, so let's put arbitrary. Okay, and you are able to see the signal in here. It is the harmonic. Okay, and also you have the option to do a music, and probably you know this if you are. Okay, you can see the signal represented in audio bars, spectrum analyzer bars. Okay, let's put this again in a sine wave. Yeah, modulate the sine wave. Yeah, and you can see all the information in here. So I didn't connect this to an audio source. It will show a better information there. Okay, but the arbitrary will show you more or less. Okay, let's do a sweep and a modulation of this. Okay, in terms of FFT, that's it. Let's move on. Okay, let's talk a bit now about the zoom. I already shown that you can have zoom by pressing function and the V option. You can control the zoom area with S and NS, and you can see also the zoom area using the arrows to move in the sample memory. Okay, so basically those are the functions. You can go up to nanoseconds, 100 nanoseconds right now in this signal, and the maximum should be 10 seconds, I believe. No, 20 microseconds. Okay, the zoom function is basically this: activated and deactivated the function and the zoom here. Let's now see the frequency counter. I'm with 100 kilohertz frequency. Okay, and I will move this to 1 megahertz. Okay, let's do auto, and it's detecting quite well the 1 megahertz of frequency. And we have also the counter. It cannot be at the same time. This is the pulse counter, and you can have one or the other, but not both at the same time. It seems to work fairly well, both of them. Okay, that's it. If you want to use the pulse counter, you have it here. If you want to use the frequency meter, you have on the bottom also, but this is a 6 digits frequency meter. So all things done, let's move this again to sine wave, and we are going to start the testing of bandwidth. For that, I will put my VPP at 1 volt, VPP, okay, and let's see just how it handles 1 hertz. Okay, so I have it now in 1 hertz. That's 1 cycle per second. Let's do it in auto. And it kind of has some difficulty with 1 volt VPP to understand what is going on. Let's try it with 5 volts. Auto again. Yeah, it's not picking up really well, but this is really a low bandwidth. Let's see, 100 hertz. Okay. Now it's detecting 100 hertz. Let's see if we can, yeah, now we have a pretty decent signal. Okay, let's try 50 hertz. It's a common frequency in electric signals. Okay, it works pretty well. So now let's start increasing this to bigger bandwidths. I will start with 1 megahertz, so I think we already saw it. And since we have 1 volt VPP, this peak-to-peak shouldn't go under 720 millivolts, more or less, to make sure that the frequency is, as it is stated, the 80 megahertz in here. So let's boost this to 20 megahertz already. It's a quarter of the frequency announced. In terms of bandwidth, it's detected very well. And we are still with 900 millivolts peak to peak. Okay, 40 megahertz. Okay, we have a small drop in here. Let me do an auto just to be sure. The frequency, it's almost there. In here it's signing 4 megahertz. Peak to peak, still good. Okay, let's do a, oops, not this. Let's do a 60 megahertz. 3/4 of the announced bandwidth. Let's do an auto. So in this frequency, we have 37 megahertz. This is not okay, but in the bottom we have 60. So this one is not working as expected. Okay, and let's take this to 80 megahertz. It's the maximum announced analogic bandwidth it supports. I don't know what is going on with this frequency counter, so I will deactivate it. It is not correct, but this one in the bottom, it's correct. So we have 80 megahertz. Peak to peak seems okay, very well. ZEEWEII says this can go even up to 100 megahertz, and that's what I'm going to do. 100 megahertz. Okay, we start to see that the signal has a bit of a problem. It's ondulating a bit. Okay, but we have here 100 megahertz. It's working, and the maximum is 5 nanoseconds, and we have a peak-to-peak more or less around 700 millivolts. It oscillates a bit, but don't forget that this is sold as a 80 megahertz oscilloscope and not 100, but even so it's being able to go there. Move a bit to the side and let's start to go 90 megahertz. Seems okay. And the VPP is over the 700, or at least at 720 more or less millivolts. So I should say that this seems to be a 90 megahertz oscilloscope, and that's great because normally this device never do have the bandwidth capacity that they sell. So you can go up to 100 megahertz, but to be sure that everything is as expected, 90 megahertz it's accepted. Pretty happy with this. Seems to be fulfilling what is announced. Very well, ZEEWEI. Regarding this signal generator of the DSO1C81, I have my oscilloscope already configured with my probe connected to the DSO1C81, and it is outputting currently 1 kilohertz sine wave, and yeah, it is outputting with 3 volts, and you can see it here in the screen, and the frequency it's pretty accurate, 1 kilohertz. Okay, to activate or to enable or disable the signal, you just do run stop. As you can see right now, it's on the screen red off, and if you press run stop again, it will be green and with on. And to change between the waveforms, you can use S and S, so we have different waveforms, as you can see. Let me count them. So 1, 2, 3, 4, 5, 6, 7, 8 different waveforms. Okay, and the manual says that you can go up to 5 megahertz in terms of sine waves. Let's start with that. Okay, increasing up to 5. Yes. And let's put this in megahertz. Okay, I have to do an auto. Considering that this is the maximum of the signal generator, I'm happy with it. You are on the maximum. You have a little, deformation here in the bottom, but the top is okay. Yeah, it's okay. And if you have a square wave, for example, it should have a maximum of 1 megahertz. And as you can see, it is already. Let me use this so I don't cover the image. As you can see, it changed immediately to 1 megahertz. The signal, it's not the most, well, you have here round corners also on 1 megahertz. Again, considering that you are at the maximum, it's not bad at all. It's not bad at all. So let's see the maximum of the signals regarding the remaining signals. Okay. This one is good, a little affected, also good, yeah. So overall, it seems a pretty nice signal generator for a small device. Let's just see the changing the duty cycle. We can change the duty cycle, and I will change also the frequencies. So, oops, I'm moving. Okay, kilohertz. Let's do it auto again. And okay, like this we can see it better. And let's try again to move up the duty cycle. Okay, works pretty well. Okay, 50% again. So in terms of function generator or signal generator is what we have. And I must say, again, I'm pretty happy with it. A very nice device that you have here. And now is teardown time. Okay, let's start by seeing the battery. So this seems to be a 2000 milliamps battery. Okay, very nice. And in terms of the construction, this looks really good. Okay, they are improving a lot. It has a shielded protection. Very nice, very nice. I will disassemble this and let's put it under the microscope. Okay, let's start with the bottom of the board. It has a very nice look, seems very well constructed. As you can see, we have here the place to put a 18650 battery, okay, in the bottom. We are not using this battery because we have a connector here on the end. Where is it? It's on the other hand. I will show you in a bit. But I think it was initially thought to use a 18650 battery. Okay, the board itself, it's really well designed and seems to have a very nice quality. The first device we have here is this Winner Micro W806C200. This is a 32-bit processor with 240 megahertz with 1 megabyte flash and 288 bits of RAM. It has a lot of things going on in this processor. I think it is used probably to control the monitor or the screen, but not sure about that. And we have another one in here. This is a CH340. Let's see if we can get some, yeah, CH340N. And this one is, well, I don't know how we don't see this more often in this kind of devices. This is a USB to warp bridge. It's basically a serial communication controller. We normally see these in small devices, that modules that connect to the Arduino and stuff like that. But it's a very popular controller. Okay, and let me see, nothing really relevant in here. Okay, we have in this side the battery connector. That is a lithium 2000 microamps hour battery. And we have this IP2312. This one is not very common in these devices, these oscilloscopes. That is the TC4056A. It's much more common in this kind of devices. Okay, so let's see what else we have. We have in here the USB Type-C socket and also the output for the signal generator and the BNC connector. So this one is the sub-miniature signal relay from ONCFA. I think that's the way we say it. Let me check. Yeah, it's ONCFA. This is a relay. Very common in these devices, these oscilloscopes. And we have in here, let me check, the 74HC4051. This is a 8-channel analog multiplexer, demultiplexer. Also very common in this kind of devices. And we have a scratch IC in here. It's not possible to understand what was this IC, but also a very similar one connected to it. It's the AG32VF. and this one is a MCU with a processor with a max speed of 208 MHz, SRAM of 128K, and a flash memory of 1 megabit. It supports SCAN, UART, I2C, and a lot more things in it. And also 3 12-bit 1 megasample per second ADCs with 17 channels. So this is awesome, this processor in MCU. Yeah, and all this, as you can see, that white strip is protected by this metal box that was delivered. I remove it, and I don't think that we have anything else in here worth mentioning. Let me see. No, wait, there is more. So on the back, this small one, it's a low power rail-to-rail operational amplifier. It's the VM358, and on the side we have this one here. We have a OPA 2673 dual high output current operational amplifier with active offline control. This small guy in here. And this one is also IC that is very common in this kind of devices. We are talking about the KY 214 series, and this is a solid state relay MOSFET. Okay, and what else? I don't think that we have anything else to show. So let me close this and assemble everything back. Wrap-up time, and let me begin with the price. It is being sold at ZEEWEII AliExpress official store at 46 euros or around $49. And this is just a literal exchange rate from the euro price I get. Probably my American friends can get a much lower price in the US warehouses. This is a nice price for an 80 MHz scope with 250 megasamples per second sampling rate, considering the products available on the competition and their prices. I think this is a solid offer. But not only because of the price, there is more to it. The quality in general is great. It is a solid product, but more important, respect the announced specifications. If you saw the bandwidth test, you understood that even if it is rated as an 80 MHz oscilloscope, it was able to process a 90 MHz signal without any problem, and without having the peak-to-peak voltage drop below the -3 dB mark. Also important is the 250 megasamples sampling rate that is not very common in these small oscilloscopes, normal being much lower, around 40 to 50 megasamples per second. The provided functionalities are also good and work great. In this price range, it's not normal to have a FFT, cursors and zoom functions, among others offered. So it's fair to say that this is a very complete oscilloscope for its price range. ZEEWEI, through the years, has been providing us with consistent good products, and this one is another win in their range of products. If I had something to point out that for technical usage is not really important, is the graphics on the interface that are a bit dated and could benefit from an upgrade. But that said, between having a dated interface and being a technically good device that respects the announced specifications, I go with the second one every day of the week. It's just a suggestion for future. It will be a good to have. I didn't record in the video, but that's something people always ask me. And yes, you can use it to measure 220 volts AC, but don't forget to use the probe 10 times, and that a small error might hurt you. Other than this, the hardware seems good, responds fast and works great. What else can we ask? As you can see, the overall usage experience was good And if you are considering to buy one and enjoy my videos and you want to support the channel, you may sponsor it by using the affiliate access links on the screen or in the description whenever you need to access AliExpress or Amazon to do your shopping. You will not pay a cent more, but will sponsor the channel just by using these links. Thank you all for your help. You know what else doesn't cost a cent more? You're slapping the like button to support the channel. And if you are new here or just didn't subscribe yet, let me tell you that every week I receive new test equipment to review, and by hitting that subscribe button you will be on the loop with everything new that arrives to the market. That's it for today. Thank you for your time and company while watching this video. I hope to see you in my next one. Until then, take care.